Láti rẹ̀ láwọn lélẹ̀.
Oh, sorry. Is there a class rep? Is there someone I can reach out to if I have a question? Is there a class rep? So can we appoint a class rep? Is there anyone who is interested in being the class rep? You can indicate by raising up your hand. Do you want to be the class rep? If you want to be the class rep, can you indicate by raising up your hand? Okay, so I'm not going to waste time on that. I think you guys can always appoint a class rep later on. So I think we have a good representation. Like before I stepped out, there were just about 4 people, but now we have the number is good. Okay, so great. So as we said, we are going to be talking about business analytics this afternoon, and so I will not spend a lot of time on introductions. I think to a large extent I know a whole lot of people here, and I can always know more about you. And so we'll just go straight to let's get started. Okay, so a lot of you guys must have heard a lot or read a few things about analytics. So according to a professor of Harvard, Peter Feder, Peter Feder is a professor of University of Pennsylvania. Yeah. So he defines analytics as the application of statistics, mathematics, and computational techniques in identifying patterns and relationships within data sets. So when we talk about analytics is that art and also the science of looking for the complex relationship between data sets using maybe mathematical or statistical or computational techniques. So anything that we do that will require us looking for patterns within data sets, that is analytics. And analytics itself, it's like a tool, or it's a means to an end. It's not really, analytics is not really an end in itself. So in order to engage in analytics, there are 3 key components that come into mind. One of them is data. The other part is the technology, and the third part is competency. So when you are doing analytics, or when you're engaging in any analytics project, the raw material, the basic component of analytics is it's data. The same way for those of you that went to universities of technology, where they probably study stuff like animal science, you cannot do animal science without an animal. You cannot do plant science. My Greek science, you can't do it without plants or animals. You cannot do veterinary medicine without animals. You can't do human science, medicine. You can't do that without, they start with cadaver, a dead human being before they start operating on live human being. The same way when it comes to data analytics, when it comes to analytics, the principal building block for analytics is data. And the data comes in different forms. The data can be structured or unstructured data. So most of the time when you deal with rows and columns, or you have to fill a form, if you have to fill a form where you put your name, your email address, your account number, your date of birth, and so on and so forth, that is a kind of a structured data set that is organized in a very logical way. Then you also have data sets that are unstructured data sets that you cannot really organize them in form of rows and columns. So when you look at when someone is tweeting on social media, somebody is writing a tweet on Twitter, or someone is posting a picture on Instagram. Those are also data sets that can be analyzed, but they are not structured data sets. Then also, if you have if you have surveillance cameras installed in your building, for instance, the surveillance camera, it's also collecting data. It's also collecting video data about your surrounding, but the data set is also unstructured. That is a kind of unstructured data. Why structured data is like if you look at a company like a bank, or correct, if you go to a bank, you have an account number, you make a deposit, and you have an account balance. When you make that deposit, your account balance changes. It is kind of structured into rows and columns. So anywhere you go to, it's always going to be the same thing that you are going to have on that account. Then data also can also be characterized in a different way. You also have the big data. You also have a classification of data which is called the big data, and that characteristics or big data is characterized by high volume, high velocity, and high variety. So what that means is that when you have data sets that is voluminous, a huge data set, that is also that is a characteristic of a big data. Then if the data is, apart from being voluminous, if it is changing very frequently, so you will look at a company like, I like giving very practical examples, and so the examples is what will differentiate this training from maybe what you see in some of these other platforms. So when you see a company like MTN Nigeria has 65 million customer base, 65 million. So let's just assume that maybe in a month, in a 30-day calendar, it's just say 50% of this 65 million that will make a call. So that is about maybe 37.5 million customers will make a call in a month. And then let's assume that this 7.5, maybe they made 10 calls in a month and they received 20 calls in a month. So you can just multiply the 37.5 million by 20, then plus times 2 again, that is by times 40. So when you look at that, that means in a month, MTN would have like lines of calls that is in excess of, say, 165, 135, 130, 260 million records generated just in a single month. So in a single month, 260 million record. If you multiply by 10 months, that is like 2 point something billion records generated. And at times they will need to do analysis of maybe 3 years or 5 years kind of analysis. You can imagine how voluminous that data set would be. So that's a classical example of big data. When you see a platform like Facebook platform where Facebook is even more than the biggest continent, there are like 2 billion users of Facebook. So imagine if it's just 50% of these Facebook users that updated their profile in a month. That is like 1 billion people updating their profile in just a single month. So you can imagine how huge that record is. That is big data, or that is big unstructured data set. And people are interacting with this platform. So people are making call per second. People are making call per second. People are receiving call per second. People are recharging data. People are browsing the internet per second. All of these are generating different kinds of data sets, which makes it to come in varieties. Those are some of the characteristics of big data. which again can be summarized as it must have high volume, that means very large. It must also have high velocity, it must be changing rapidly, it won't be data at rest, and to come with different varieties, it will come in different formats and different varieties. Those are some of the characteristics of big data. We cannot engage on a data project without we can't engage on a data project, or we can't engage on analytics project without having data. During the lockdown, we are supporting some projects before the lockdown, and when the lockdown started, the client said that no, you guys can no longer access our building, you can no longer access our data. For like a period of 2 months, Octave Analytics could not support some of those clients because, yeah, we have the competence, we have some of the tools, but because we don't have access to the data, we can almost not do anything. So data is fundamental. So beyond data, the next building block, very important, is the tool. And there are uncountable tools that are available in the market. And as part of this graduate training program, by the end of this graduate training program, you must have been proficient in the use of certain tools. But the fact that those tools, they are uncountable of those tools. You can't even count them. There are some of those tools that are publicly available, some of them are open source, some of them are proprietary. You can even develop your tool yourself. We have some guys that are working on a project with one of our clients, and the tool that they needed to do the data migration was not available because they're working with a database that is it's Sybase. They were working on Sybase database, and they needed to migrate data from Sybase to MySQL. These guys had to use a Python script they had to develop their own ETL tool that will extract data from a platform and load it into a different platform. Although before now there are tools that can do that, but for this particular problem or in this particular case, that tool they could not really lay their hands on it too, so they had to develop their tools. It's also a kind of analytics tool. You have Power BI for visualization. You have Power BI for visualization. You have Tableau for visualization. You have Excel for visualization. You have TeamCell for visualization. For predictive analytics, you have SAS Enterprise Miner, you have NIME, you have Microsoft Azure, you have Python, you have R for data mining or predictive modeling. For descriptive modeling, you have tools like Excel, you have SQL, you have Oracle SQL, Microsoft SQL, and so on and so forth. So all of these tools, they are tools that are all going to facilitate data analytics. So when the data is huge, when the data is large, it becomes cumbersome for you to manage as a human being in a manual way. So in that case, you would need to invoke the right tool. So to put that a little bit in context, so you imagine, say, you're driving a car on Third Mainland Bridge. So while driving a car on Third Mainland Bridge, so the car broke down on Third Mainland Bridge. So and you can tow the vehicle with an ambulance. If the car broke down, you can decide to tie the broken down vehicle to an ambulance and tow it to maybe your destination. But the ambulance is not the best tool for towing a vehicle. You just need to look for a tow van to move that vehicle to your destination. So also the knowledge of the right tool to apply on the data is very, very important. You can use your saloon car to also tow a vehicle, but that is not what it's meant for. If you continue to do that, after a while, that tool is going to break down, or you are not going to be efficient if you are using your own saloon car to tow broken down vehicles on the bridge. So the knowledge of the right tool to apply on a data set is very, very important. Then the third element of analytics is competency, which is also part of the learning points. Competency. The competency can come in form of domain competency or in terms of analytics competency. So domain competency is understanding a particular environment. So if you are working in telco, for instance, or telecom is a domain, financial services, banking is a domain, insurance is a domain. So for instance, if what we call phone number when you go to a bank, no, when you go to a telecom company like MTN, Airtel, Nine Mobile, and the rest, when you go there, when you mention phone number, they will probably laugh at you because there in that domain they don't call it phone number, they call it MSISDN. They call it MSISDN. What we call account number, that 10-digit account number, when you go to a banking environment, what they call it is ACID or for ACID. Those are that is their language, that is their domain. And that ACID or that for ACID, that account number, there are more details to it than what even you as an outsider what you know about it. So if you don't have that domain competency, it will be difficult for you to be able to perform analytics on data from a particular domain. And that is what actually makes the difference between experts and those that are not experts. Those that are not experts probably know how to use the tool, but expertise will come with knowledge of a particular domain. I also want to tell you this. So the first time we're going to do a project in the bank, so we needed to identify transactions, for instance, that are USSD transactions. And we just thought that, okay, maybe if we search for a string where we see USSD, maybe that will just explain it. And guys, we did that for a period of 6 months. We were just cooking beans. We cooked beans for a period of 6 months. Until a day, somebody just checked and said, no, this report does not make sense. That no, we don't have up to this number that you are reporting, that you are over reporting our number. Then they asked the question, okay, how are you getting the USSD customers? Then we said, this is how we got it. They said, no, that is not how to get it. And they told us exactly how to get it. And then we changed our script and we ran it. But we did that, we cooked beans for a period of 6 months. So welcome to the world of cooking beans. You too will also probably cook beans until you become an expert in a particular domain. But that is the domain competency. Then there is also the analytics competency, which has to do with the know-how of algorithms and the tools and the concept to apply. Again, as I said to you, you want a car broke down, you have between a saloon car and an ambulance and a towing vehicle to tow the car that broke down. The truth is that 3 of them can actually tow the vehicle that broke down. 3 of them can tow the vehicle that broke down. So you can actually use 2 that will give you results, but it is only one that will give you an efficient and effective and a cost-effective and a time effective result, because that is what it is designed to do. That is the towing vehicle. The towing vehicle is designed to tow a car that broke down. It's not an ambulance. So when you use an ambulance, yes, you might also get a result. If you use your saloon car, you may also get a result, but they will all come with a cost, and it will be too expensive at the end of the day for you. Feel free to unmute yourself and ask me questions at any particular point in time. So just to summarize the building block of analytics, analytics itself is a complex function that is made up of data, technology, and competency, each of which is critical to the process of, and they cannot work in isolation. Data cannot be there in isolation. If you have data, if you don't have the tool, it's useless. If you have data and you have the tool, you don't have the competency. If you give me data from maybe a particular industry, maybe maybe some data from the moon, or you give me some data from maybe the Mars to analyze it, I'll probably not be able to analyze it because I really don't understand anything in that particular domain. So competency, the tool, and the data, they all matter, and they work. They are interdependent. Yeah. So please feel free to ask me any question at any point in time. Stop me, and I don't think there's any question that is a stupid question. So please feel free to stop me at any point in time. Then, so in terms of the different levels of analytics, so analytics actually comes in levels. analytics comes in levels. It's when you want to engage on a project, analytics project, every company is not exactly at the same level of maturity. You know, some of them are advanced, some of them are maybe in the middle, some of them are just at the beginning, some of them are completely at ground zero. So this particular chart tries to depict in a generic form the different levels that a business can actually be in terms of the implementation of data analytics projects. So the most basic level is the level of maybe there's anything like no data. So if there's no data, then there's even no analytics at all. So the basic level is the level of raw data. So you have companies, you have businesses that just collect data, you know, they just collect data and that is all they do. You know, they collect data and that's all they do. You have that you have the level of raw data. To put that in context, so we had a company where we worked for. It was a telecom company. So telecom companies generate. Please take note. Some of these things you will not find them anywhere. You will not find them anywhere. Most times when people do analytics training, they are probably teaching you about tools. We are going to be training about tools, but this particular session is about practical applications of some of these concepts. So, so this company generates what they call CDR. It's a telecom company. CDR is standard in telecom companies. So when you go for interview in a company like MTN, for instance, and when you talk about things like CDR, they will know that yes, this guy is an expert. He knows what he's talking about. So when you make a call, the network generates generates what they call a log of that call. That log is called the CDR. So that log will have the number that is calling, the number that is called, the time that the call was initiated, the time that the call was terminated, the duration of the call, the number of minutes that you spent on the call. It can also contain maybe how much you spent. So if it's configured to have how much you spent on the call, and so on. The base station, exactly, okay, the base station that originated the call, you know, the base station that terminated the call, that is called a CDR, you know. So when you make a call, you generate a CDR. When you are browsing, like now you are browsing now, you are on a e-conference section, you know, you also generate CDR. When you recharge, you know, you also generate CDR. When you do anything in the telecom space, you generate CDR. So this telecom company, all they do is that they just collect the CDR and they dump it somewhere, and that was all that they did. And they called Octave Analytics. Octave Analytics, see, please, we have this CDR, we've been collecting it for like 3 years now. Please, can you help us in building an enterprise data warehouse? So, oh no, can you help us to build an analytics platform? That was what they requested for, you know. So which will have to take us through the EDW, BI, and analytics stages to get to that point. So that is the level of raw data. That is the level of analytics at which the company existed then. So when the data is raw in that format, what we need to do is to now do what is called ETL. ETL stands for transform, extract, transform, and load. So ETL stands for extract. So the data is in some file that is dumped on some server somewhere. You extract the data, then you transform it, and then you load it into a database application. That is ETL. Extract it, transform it, and load it. So if the CDR has when the call originated, the time the call was originated, and the time the call terminated. If it does not have the duration of the call, by the time you are extracting that data, you can transform it by subtracting the time the call was originated from the time the call terminated in order to compute the duration. So you have a new field that is called duration. That is a transformation, very simple transformation. That new transformed data you load it into a database where you can always reference for a particular number the total duration of minutes that that number has spent making calls, you know. So very simple stuff, but it's very, very, very important. If you cannot go through that ETL process, there's almost little you can do. We're also supporting a fintech company. That fintech company is like Paystack, it's like Paystack, it's like InterSwitch. So what they do is that they generate a lot of payment transactions. So when they generate these payment transactions, uh, yeah, when they generate these payment transactions, the data is just it's just there. It's just there on the database. That's all. They don't do anything with it, you know. So what we had to do was to create what they call enterprise data warehouse, where we first of all uniquely identify a merchant, you know, a unique merchant, and then we now go and look for all the transactions within a particular day, and then we store it. What are all the transactions generated? What are all the transactions generated by a particular merchant on a particular day? Then we store it away, and then we go to another merchant, and so on and so forth. So those are ETL processes, and the whole of that process is called enterprise data warehousing. It is the basic. They are still very basic. It's called enterprise data warehousing level. You know. So beyond that point, the next point is the standard. The next point is the point of building standard reports. You know, or the point of building standard reports, and we yeah, so and I will so standard report is okay. So if you have generated, if you have extracted the CDR and then you have computed the minute from the originating time and the terminating time, you've computed the CDR. So you may want to ask, the CEO may want to ask the question that what is the total minute of call that we generated in a month? You know, what is the total minute of call, or what is the total number of customers who made call in a day or who made call in a month? You know, very basic standard reports, you know. So from there you can do standard report, you can do ad hoc report. Ad hoc report could be something like, oh, what is the impact of COVID-19 on our call? So we'll be making calls before the lockdown started. Now there is a lockdown. Do people now make more calls during the lockdown, or people made less calls during the lockdown? The question that a lot of people have been asking is that they know that, okay, they have generated a lot of data, they generated a lot more data session during the lockdown period since this COVID-19 started. But the question is that, okay, can we even look at the data? So have people generated altogether, have people done more data session during the lockdown, or they've done less data session during the lockdown? That is some kind of an ad hoc report. If there's no lockdown anymore, that report will no longer be interested. It will no longer be interesting, or nobody will have interest in such report of COVID-19, because by 2021 we have moved on from COVID-19. We are probably focusing on something else. So that is the level of the ad hoc report. Then you can have a deep dive. We do a whole lot of deep dive in this company, where we are trying to investigate why a particular incident is happening. So you want to do a deep dive, and you want to you want to answer every little bit of question about a particular entity or about a particular incident. Deep dive. Then beyond that, you can go to the realm of analytics, statistical analysis, where you are investigating probably what happened, what is the frequency of that happening, what is the mean median mode, what is the variance of that occurrence, what is the standard deviation, and so on and so forth. So in this level, this is business intelligence level. And one thing that is unique to them is that they are looking at what has happened in the past. So you have the black line, which is just extracting data raw and is organizing it in a way that is accessible. The realm of business intelligence is the realm that looks at data in history in terms of what has happened in the past, and is analyzing it in order to be able to present that to the business or to look for insight. Then you now have the analytics level. Analytics is forward looking, business intelligence is backward looking. So analytics is looking for insights, but in a futuristic manner. So we want to predict. Okay, so next month is the month of August 2020. How much are we going to make in the year 2020? How much customers are we likely going to acquire in the year 2020? Yeah, how much sales, how much revenue, how much cost are we going to incur? That is the realm of prediction. Then you now have the realm. Okay, so that is prediction. Then beyond that, you can also do forecasts where we look at trends or on a continuous basis, you know. So if a trend continues on a particular basis, so based on that, we can make some forecasts. And then we also have a level of prescription where we now start making recommendations in terms of what is the best thing that can possibly happen. So what will happen? There is one that's asking what will happen. Then the other is that what is the best that can possibly happen? That is the realm of optimization. All of these can also be regrouped. Analytics itself can be regrouped in terms of maybe it is descriptive analytics or predictive analytics or prescriptive analytics. So descriptive analytics is looking at the past, predictive analytics is looking at the future, while the prescriptive analytics is trying to recommend the best course of action, you know, for something that would likely happen. Again, please feel free to ask me any question. You can unmute yourself and ask a question if you have any question. But those are different levels of analytics. And for each of this level, again, if we go back to this, that it will require data, it will require technology tools, and it will require some level of competency, you know. So if you are doing raw data, there are tools that are required to capture those raw data, you know, and you also need to understand the domain. If you are doing ETL on data, if you are doing extract, transform, and load, there are tools for doing ETL on data. If you want to build standard report on data, you must have the data and there are tools that you apply, and there's a competency you need to have before doing those standard reports. If you want to do prediction on data, you are going to need the data. There are tools that are built specifically for those type of predictions, you know, and so on and so forth. And competency is also required. So this part is very, very key. I'm going to pause a bit and grab a bottle of water, then I'm going to continue. But before then, I'll quickly rush through the different the analytics life cycle itself. So if there's analytics project, or if I want to undertake analytics, not analytics project, if I want to undertake analytics, what are the different stages that I have to go through? You know, if I want to engage in analytics, what are the different stages that I have to go through? So number one question, number one step is when you undertake analysis, or the analytics life cycle. Number one step, the first step is to ask question. I'll take a pause. I'll pause, then I'll grab a bottle of water, then I'll continue.
Okay. Yeah, I'm here.
Thank you, thank you, thank you. Oh, thanks, Hope. I didn't know I was on mute. I've been talking. Okay, so thank you. I've actually been talking. Okay, so we are looking at the different um, stages of we are looking at the different stages of analytics, and it starts with asking a question, asking the right question. And for you to be able to answer, to ask, not to answer now, to ask the right question, domain competency, you need to really understand the domain for you to be able to ask the right question. So you start with ask the right question, or asking a question. Um, and it could be as simple as, how many customers do we have? For one of our clients, then this client have been in business since 2004, 16 years now. But if you ask them, until we started engaging them, that how many customers do you support, as a business? They've been around for 14 years. They couldn't tell. They couldn't tell until we started supporting them, and we had to put a whole lot of work into the data before we could even be able to answer how many unique customers they support. But it's very important, because if you don't even know your customers, you cannot tell whether you are making more customers or whether you are losing customers. So it starts with asking questions. Then the next stage is prepare to prepare the data. That has to do with identifying the different relationship within the no no that has to do with providing, maybe extracting data, transforming data, and loading data into a platform, and then modifying it in a way that can help you to now perform the kind of, to provide answer to the question you are trying to answer. Ask the question, then prepare the data. Then the next point is to explore the data. Exploring the data is with the point where you look for patterns and relationship between the data set. It's that analytics point where you do a whole lot of data relationship mining within the data set, or pattern recognition within the data set. At some point, for data exploration, you may even need to form a hypothesis in your mind. So data exploration. Then the next stage, once you have explored the data, then you build models. You build models, especially for those questions that are going to be repetitive. If a question is going to be repetitive, if a question is something that that your client or your manager is going to ask again, or the business is going to ask again, then you build it into a model, because you don't want to go through the process of data exploration, data preparation, and data exploration all over again. When you build it into a model, it minimizes the time that you spend in preparing and in exploring the data. So a model is like it's like automating repetitive tasks. Yes, a model is like automating repetitive tasks. So after building a model, then the next thing is to implement. That is the point of deployment of the process. Is the point of deployment, where you define some business rules and you generate some library or data dictionary for a set of tasks that are repetitive. Then the next thing is to act on whatever recommendations that comes from the implementation of that model. Some of those recommendations could be like, get more customers. Some of those recommendations could be like, oh, reduce your costs. Some of those recommendations could be like, oh, at this point, you need to optimize, or you need to campaign, increase your campaign. That's what they call campaign management. Like, okay, sell more, tell more people about your product. Those could be the recommendation. It could also be the act could be, okay, incentivize the customer, give them some incentives. That could be the recommendation that could be the recommendation you need to act on in order to move the business forward. And once that is done, the next thing you do is to evaluate. So I have performed this action, and I performed this action within a period of 2 months. After performing this action within a period of 2 months, then I evaluate to see what exactly is the outcome of the action. Was it positive or negative? There are some cases where you perform a particular action and the result is negative. In HR analytics, there are times that you perform a particular recommendation and the outcome is negative. In campaign management, there are times that you run a campaign and the result of that campaign is negative incremental revenue. In that case, what do? That means you need to stop that. You need to stop that campaign because the result is it has an adverse effect on your business. So after evaluation, then that is going to generate another set of questions. If you generate another set of questions, you go through the loop all over again. So it is continuous. As a data analytics person, you would your work will likely never ever end, except if you are not creative, or except if you're a dormant person. Except if you're a dormant person. I don't think that as a data analytics person, there is never going to be a time that the business will never need you, except if you yourself are not creative, or maybe the business does not like the output of, does not like the kind of work that you generate. That is probably when you probably be docile at some point. But in most cases, there's always another question to ask. So if the business is performing well, maybe at the end of your model, after evaluating, if the result is good, they'll ask you a question. What exactly happened that the result was good? If the result was negative, they ask you what exactly happened that the result is negative. If the result is flat, they will ask you what can we do to make it better. So there is no point. There's never any point in time that you as a data analytics person, a business analytics person, will not have a job to do. And that is why the demand for data analytics keep growing every now and then. According to World Economic Forum, it's one of the top skills that are in demand. So I think you made the right decision by being here. Please ask me any question. If you don't have any question, I'll keep on moving. So I will allow for 1 minute for you to ask me a question. Please, questions, please. One question at least, so that I know that I'm not the only one that is here. Okay. Can I move on?
Yes, sir, you can move on, sir.
Okay.
My hand is
up.
Yes, sir, you can move on.
My hand is up.
Okay.
Sorry, I have a question.
Okay, correct. Somebody has a question now. Please do ask me.
All right. I'm a real Oli. I've been following so far, and when you started, you mentioned the 3 pillars of analytics, and you mentioned the aspect of competency in the having knowledge of the business domain. So I was wondering, you said that some people might not have idea about or knowledge of some concepts in the business. So I believe that is that not supposed to be covered in the aspect of in the first step, ask, that is present here. Like, so if you have any business you want to do any project for, you probably ask and understand all the concepts or all the ideas of the business, because no matter, I don't think as a data analyst you can always know something about every field in essence. So I think, is it not supposed to be something you can always ask them before you start their project at all? Like you always ask about all their terms, all their terminologies that they use in their business, and they give you all these details before you start the project, in essence.
Okay, so thank you. So that's not the ask. That is not the ask, and that is not the competency. Um, that's not the ask, and that is not the competency. So that ask is like a business requirement. It's like a business requirement. What do we need to do? So what we need to do would necessitate the kind of questions that we want to ask. So um, so imagine a business requirement could be something like something like maybe um, what is the percentage change in the volume in the revenue generated during COVID-19? Okay, so the question could be something like this. The ask could be something like this. What is the impact of COVID-19 on our business? That is a business requirement, you know. That's a business requirement. It's if you don't understand the domain, if you don't understand the domain, you cannot answer that question. And you can ask that question across multiple domains. You can ask that question in telecom business. You can ask that question in banking business. You can ask that question in insurance business. If you are in logistics business, you can ask that question in logistics business. You can ask it in transport business. What is the impact of COVID-19 on our business? That is simply asked. It's a business question. You know, it's a business person that asks that question. Now, the competency has to do with the knowledge, the know-how that you have to be able to provide answer to that question. So, if the MD of a bank comes to you and say that, Ebube, what is the impact of COVID-19 on corporate banking? So, First Bank comes to you and says that what is the impact of COVID-19 on First Bank corporate business or First Bank USSD business? You know, you need to really have a lot of domain expertise, you know, and it has nothing to do with the question that they have. Well, maybe it's related to the question, but you need to have that domain expertise. And it's not going to be by you asking some questions. If you're asking some questions, then they'll say this guy does not even know. You cannot answer the question that we are asking. Sure, you understand. So the competency and the question, they are like two different things. There are two different things. The competency is the know-how, is your own understanding of that environment and the know-how that you have. While the ask part is like a business requirement for a task that you need to perform. Is that clear?
Yeah, that's all right.
Okay, thank you. Okay, so I'm moving on. Okay, so I'm going to skip this slide. No, I'm not going to skip it. I should have deleted it. Okay, so there's a roadmap. So I feel like I should edit it. Okay, so I'm going to edit it before I share this. So there's a roadmap for analytics. So if you are going to implement analytics within a particular establishment, if you are going to implement analytics in any business, there's a roadmap you need to follow. So you can also find yourself in a company that they don't even have analytics at all. Or if you are going to engage a business owner on the implementation of analytics. So what are the we've talked about the elements, the key building blocks. We've talked about the data, the tools, and the competency itself. Then we've also talked about the different levels of analytics that can be. But when we talk about roadmap, so roadmap is that what are those steps that you need to follow in order to be able to build analytics capability within a particular establishment. So the first thing you need to consider it's the business layer. Analytics is more of a business. It's more of a business. What's the word now? The word is it's more of a business requirement than technology requirement. For most of the places where we have worked, most of the places where we've worked, it is the business that initiates the need for analytics than the technology or than the technical department. However, um, there are cases where it is the technology people that are driving it. But in most cases where you have the business people driving it, we are usually more successful in those environments than the environments where it is just the technology people that are driving it. Most of the technology people, they are only interested in those tools. The technology people are interested in the architecture, they are interested in what database are you using, what tool are you using, how are you doing it. But the business people are more interested in the value, the naira value of it. How much cost is this reducing for me? How much money is this insight generating for me? And so on and so forth. So the first layer for analytics roadmap, the first layer for an analytics roadmap is the business layer, where you define the business strategy. What exactly do we want to achieve with this? So if this company, say that company is called Octave Analytics Limited, they don't have any, they don't have analytics within their strategy, and now they want to adopt analytics as part of their business strategy. So the first thing you may want to ask is that what exactly is the business objective? Let's know where. So first question you may want to ask is one question you may one question you may want to ask is what is the business objective for adopting analytics? That is the first question you may really want to ask. Then the next is, so there may be so many questions that you may want to ask. Then the next one is to prioritize. You need to prioritize. So out of all of those business objectives, what do we need to prioritize? And then you now, from those point of priorities, or from those main priorities, then you now need to also identify what are the areas to focus on, because the applications of analytics, they are just so much. They are so much. I'll tell you a company. So this company has analytics in. So this company has IT department, has marketing department, has finance department, has sales and distribution department, has enterprise department, has network group, and has customer care department. This same company has senior manager analytics in marketing, has manager analytics in IT department. They have senior manager analytics in sales and distribution department. In fact, they have a general manager analytics in sales and distribution department. They have a senior manager analytics in enterprise department. They have a manager analytics in network group department, because there are just so many areas of there are many priorities across different business groups. So they had to create different business units across all of these points, and now create an analytics manager or someone who is going to take charge of analytics across those different business domains. So it's very, very important. Then the next thing you need to do is to assess your level of maturity. For that business, the business needs to identify what is its level of maturity. If you look at what is it called? If you look at this slide, that is this slide. So this slide would help you to identify, okay, what is the level of maturity of the company or that business unit? Is it raw data? or they already do ETL, or they already generate some standard reports, or they can even build models, or it's only that maybe they need to build predictive models, or they even need to go to the level of optimization. So that is the business layer for the analytics roadmap. Then the next layer is the analytics layer. That has to do with translating business requirements into analytics requirements, which is also very, very, very important for you to be able to, there's a business need, but what is the analytics layer? Okay, how do you convert that into patterns and relationship within data set? What type of patterns and relationship do we need to put together? What data do we need to explore in order to be able to answer some of these questions that business have raised? What are the investments that we need to put in place at the analytics layer in order to be able to answer the questions, or in order to be able to provide for the business objectives that have been highlighted? Then the next layer is the capability level, which is what skills, what competency do I need to build within my team? What competency do we need to build in the team in order to be able to deliver analytics? Yes, it's very important. Then the infrastructure level, this is where the IT guys come in. The infrastructure level tends to answer questions around what are the technology requirements that are available in order to be able to provide analytics support within a particular establishment. Do I need to do my implementation in the cloud? Do I need to go on premise? Or do I need to develop is it that my team that currently do they have the competency to be able to deliver analytics, or we need to be able to maybe outsource it to a third party? So those are some of the considerations for the infrastructure level in terms of analytics roadmap. Now, so we are going to be looking at the different use cases. So these use cases are not exhaustive, and I think before the end of your program, you're also going to be developing. You're also going to come up with your own use case, with your own analytics model. Sorry, we are talking about analytics model now. So you're also going to come up with your own analytics model. So analytics model, it means like automating a process or a standard way of doing things. A model. So if there is a task that is repetitive that you have to do again and again and again and again, so you can build it, you can implement it in form of a model, so that you can just implement that model by calling a repeated function to answer the same question that the business might need to ask you. Note the use of the word business, because business, there must be a business requirement for any analytics undertaking. Otherwise, it's probably just going to be some academic exercise. If the business is not interested in your analytics project, then it's probably going to be useless. I can tell you that. So we have a library of analytics models that we have built at Octave Analytics, but they are more than this. I think this is just all that I can capture within a particular slide, but there are a whole lot more than this. One of them is I'll just take it randomly. So let me start with market basket analytics. Market basket analytics is what we call it in e-commerce space, but in some other enterprise environment, like in the banking space, we call it like next best offer. So how it works is that market basket analysis, how it works is that, so you go online, you buy a number of items. We can analyze those items and we'll tell you that we can analyze the content of those items, and based on that we can tell you that this is what you probably need based on the items in your cart or in the basket. So if a lady goes online and is buying Pampers and is buying diaper and is buying wipe, sanitizer, is buying wipes, wipes. it's in the person's person's shopping cart. So you know that this is probably a nursing mother if you are buying diaper, or maybe the woman has a child that is less than 3 years old. That is why she's buying a diaper. So there is what they call market basket analysis, and it's also applicable for it's an analytics model that is applicable to many businesses. It can be it can be it can be user based, it can be collaborative, and it can be a hybrid of the two. So market basket analysis can be implemented that it will be user based. User based means that it's just what you have in your basket. That is what we're analyzing. And based on what you have in your basket, you are using that to based on what you have in your basket, you are using that to conclude that okay, you probably need this particular item. So this person has gone online. The person bought a male shirt. The guy bought a male trouser. He bought a wristwatch. He bought a shoe, but he didn't buy a pair of socks. So after analyzing the content of that basket or the cart, what they call carts in online shopping, based on that, we can recommend that, oh, okay, based on all of these components you have selected, I think you will likely need a pair of socks. Why not buy this, alongside with it? So that is like upselling a customer, but based on what the customer himself has selected. I'm talking about market basket analysis. Then also it may also be that we are looking at okay, what you selected is similar to what other people have selected, but there are some other items that other people have selected that you have not selected. So based on that, we want to recommend to you. Of course, some of you already know this. So when you go to Jumia and you want to buy items on Jumia, they will tell you that people who view this product also view this other product, or people who bought this item also bought this other item. It's market basket analysis. That's what they are doing. When it is user-based, they are only checking the content of what you have purchased, and they are using the content of what you have purchased to make recommendations to you. When it is collaborative, that means they are looking at what other people have bought and they are comparing it with what you have bought, and then they are now making recommendations to you based on the based on the assessment of what you have bought and what other people that bought similar products have bought. That is collaborative algorithm. Then you also have the hybrid, which combines the two. You have, so I'm moving on to the next model. So we have customer link analytics. So if you think about customer link analytics, take your mind to a company like MTN, 65 million customers. They are all calling themselves. So when you if you decide to plot a graph of all of those calls that they are making to each other, you are going to have, because everybody will be interconnected in a particular way. So you are going to have a huge network, 65 million people within a huge network. But within that huge network, you're also going to be having smaller network. So the question is that, is there a way we can monetize the network between all of these different, is there a way we can monetize this network of relationship between the different users? Is there a way we can monetize it? So that is how customer link analytics how it works. So at times when you call some people, you hear some ringtone, then you are wondering, why is this person having this kind of a ringtone? So they have profiled that user, and they know that, so if we give this person this particular ringtone, by the time 10 people call him, since he is a class rep of his class, if we give him this, almost everybody call, if we give him this ringtone for free, and you say, if you love this tune, press 1 to copy it, out of 100 people that we call him, at least maybe one person will press, or maybe 2 people or 50 people will press it. So based on the fact that, so from the customer link analytics, they segment customers within that link into maybe the person is a leader or maybe he's a follower within a network. You know, it can be a leader within a network and it can be a follower within a network. Customer, I'm searching for customer link analytics. I'll quickly share that slide with you. Yes, I think here it is. Okay, just a minute, customer link. Okay, so I disconnect and then I will reconnect. So this is how customer link analytics, this is how it works. So within a network, so within this network, there is a leader in that network. So this guy is a guy that is actually facilitating all the interactions within this network. If you get rid of this guy within this network, then this network may likely crumble, you know. So so in this customer link analytics model, or when we can build a model that identifies who is the leader within a network, which customer is the leader within that network. If you know that leader within the network, you would want to protect that customer from churning. You want to protect that kind of a customer from leaving your network or leaving your, essentially leaving your network, you know. So in terms of retention, if you have 2 customers to save, if you have only 1 customer to save, is the leader of your network you want to save, because as long as you have that customer who is the leader within your network, you still have it. Or every other customer, they are still going to fall back to him. But if you lose that customer, the probability that you are going to lose other customers is very, very high. Then you have other people who are followers within the network. You know, they are not really leaders within the network, but they are followers within the network, and they will all to a large extent be connected to the leader. Then you might have some other guy within the network who is an outlier. You know, he's not really within the network. He has a behavior that is different from the behavior of other people within the network, but he's a part of the network. Then you have a bridge, a guy who connects a network to another network. So there's a network. So let's say there's a graduate training network, there's Octave analytics network, say there's a first bank network, for instance. So there can be a bridge between the graduate training, the graduate program network, and the first bank network. You know, that guy within that network is a bridge. So when you identify all of these different entities within a network, you will be able to monetize, or you'll be able to like implement interventions, you know, to optimize your business or your customer base. Yes, so I'll move to my next slide. No, not this. Where is it? Okay, so yeah, this is what I was looking for. Okay, so you have customer link analytics. There is BOBR. BOBR is business opportunity, business risk. It's part of the model that you are going to be building at some point. You have new value extraction model, you have regression analysis, you have churn modeling. There are just so many of them. There's customer segmentation, you know, there's customer segmentation. I'll just talk about maybe BOBR. So BOBR is like again, you have a huge customer customer base, maybe 20,000 customer base. Out of those customer base, you may want to take the average performance of this customer in a time in the past and look at it relative to how the customer is performing now. So based on that, you will now segment that customer into different buckets. So one bucket will be, okay, this customer relative to the average of how the customer was performing before, I think this customer is doing a lot better. So he's a grower, or he's a dropper, or he's flat, or he's a stopper, or he's non-user, or yeah, I think there are 6 different segments for that BOPR. So in essence, all of these try to categorize customers for different kinds of intervention. We also have location analytics, where you profile customers within a particular location to tell. So like the guys in retail banking that deploy ATM, before they deploy ATM, they deploy a lot of geospatial analytics. That is location analytics. They deploy a lot of geospatial analytics to determine the population of people in a particular area, the volume of transactions they generate in that area, the potential of that particular area before they deploy that ATM, because there's a cost attributed to ATM deployment. So when they don't perform thorough location analytics for their ATM deployment, they may actually be incurring costs for an ATM that they deploy in a particular location. There is a cost on the ATM, there's a cost for operating the ATM. So you need special kind of analytics in order to be able to like optimize the deployment of, say, ATM, for instance. And we also have fraud detection. You guys have heard of hush puppy, a crazy guy, defrauding people. Some of these entities or some of these banks, if they really have some solid system, they will be able to tell that some of these transactions are fraudulent transactions, because there's a pattern to fraudulent transactions. They don't just come out of the blues, so they can be detected even ever before those transactions, before they are completed. They can be detected and they can be nipped in the bud. I'll give you an example of that. So you see somebody who has never ever withdrawn his ATM withdrawal limit in a day, for instance. The person has never ever done that, for instance. Then suddenly the card was inserted in an ATM that is strange to where the guy has ever inserted his ATM. And what the person is withdrawing is the limit for the day, and then it's at what's it called? How do I call it now? Like an odd period of the day. It's around 11 p.m. or around 1 a.m. in the middle of the night. Just know that it's a fraudulent transaction. Maybe that ATM has been stolen, or that ATM has been hijacked in a way, for instance. So if those ATMs have intelligence, they are actually supposed to stop those transactions. Or maybe you just implement a second level authentication before those transactions can pass, But, the ATMs are just like, they are just dummy, you just press it and it brings out money as long as you have up to that amount in your balance. But when you implement some kind of machine learning or some kind of intelligence into it, then with that, you may be able to help people to save their money. Those people that at gunpoint, they are forced to relinquish their ATM card. The ATM will actually dispense money, but it will not dispense more than a particular amount, and to help the person to save what the person would have lost to some of the robbers. So those are some of the interesting models that you can actually view on analytics. They are not exhaustive. We have dormancy prediction model, we have customer profitability model, we have demand forecast analytics, we have credit scoring model, we have recency, frequency, and monetary value. There are just so many of them, and I hope that during this class you would have to build some of these models. I can assure you that you definitely build some of these models. because from next week, I'm sure the lead trainer is going to present you with some data, and maybe it's going to be a churn prediction model that you are building, or it's going to be maybe a recency frequency and monetary value model that you are building, which is some of those things that you also don't get anywhere else. So in terms of analytics, it's not like it does not come without challenges. It indeed comes with its own challenges. Some of the challenges of analytics is that it's time intensive. It's time intensive. You need to really invest a whole lot of time into analytics. You cannot have both time and share of the mind. So if there's anything like the share of the mind, it's also mind intensive. Like you really need to put a lot of time to it. Those are challenges of analysis. So, and some people cannot afford that. Some people cannot afford to concentrate. I worked with consultant for a company sometime before, and those guys they really did not have a dedicated analytics department. So they just wanted somebody that they didn't have a dedicated analytics department. So they just wanted someone that would just do some stuff, that would just build a model and then go and still do the business as usual. After doing business as usual, if there's a need to build a model, you come and build the model. I told the general manager that it's not going to work for you, because this requires like a dedicated resource who is mining the data and who is churning out those insights for you. So it's time intensive, it's also cost intensive. Although these days there are a lot of off-the-shelf open source tools that have been developed, but before now it used to be very, very expensive. And before now too, or even up until now, there are limited expertise in this particular space. But we are also trying to bridge that gap, especially for the African market. And I hope in another 5 to 10 years there will be a whole lot of experts in this particular area. And then one other challenge with analytics is the lack of process. There's no standard way of doing things. So if I build a churn prediction model, for instance, and somebody else build a churn prediction model on the same data set, we are going to get different results. And you can't even tell which one is better. You cannot exactly tell which one is better, like which one is better. Yes, maybe in terms of accuracy of the model, in terms of prediction, there are some things that will give you a better score than some other ones. But yet, you can still not tell which one is a better way of doing something, because to a large extent, it's an art than a science. But there are some principles that can guide us. There are some best practices which we are going to be learning as we proceed. So when you deploy analytics, I can pause a bit too for some questions. Please ask me questions before I move further. So I'm going to pause a bit for questions, then I will continue if there are no questions. Okay, so I assume there are no questions, so I'm going to move on. Ebube raised his hand. Ebube, do you have a question? Or is it the old one?
It's the old one. I didn't raise my hand.
Okay, thank you. Okay, so I'm moving on. So when there's analytics projects, there are some key components that are very important that needs to be deployed. Whether it's insurance or whether it is banking, wherever it is, there are some key components that need to be put in place in terms of infrastructure for you to be able to successfully implement analytics projects. One of them is that you need to have access to the data sources. So in an insurance setting, for instance, there is the core insurance application. There's core insurance application. There is another application that they call claims that hold data on claims. Some of them have data on customer care. For all of these different entities, those are the data sources. You need to be able to plug in into that data source in order to be able to extract data. You need to be able to plug to the data source and extract data. The process of extracting data from those data sources is called ETL process. In some cases, it may not really be a standardized application like this. Remember the telco example that I gave, where you have the telecom example where you have, what's it called? Where you have CDRs. Yeah, you have CDRs that are in files. That is also a data source. Even though they are just in flat files, those files are TXT format or .csv format or .unl format, regardless of what format, but they are just flat files. Those are also data sources. First thing, there should be data source. If data is fundamental to analytics process, so there must be a place where you can access the data. Those are the data sources. It could be a database application, it could be flat files, it could be whatever. Those are the data sources. Then, after extracting the data from the data sources, you place it in an environment that is called the staging environment. It's a temporal platform where it's a temporal environment where you curate the data, where you clean the data. And data cleansing has to do with looking for incorrectness or incompleteness or inconsistencies in the data set. There are 4 I's: incorrect, incomplete, inconsistent, and incomprehensible data. So there are some data. We did a project with a bank, and you see the customer had huge balance in the account, but the name of the customer is full stop. The last name is semicolon, and the customer has huge balance in his account. That is incomprehensible data. Or you have a savings account, for instance. A savings account is not supposed to have a negative balance. A savings account, a loan account can have a negative balance, but a savings account is not supposed to have a negative balance. So when you now see a savings account that is having a negative balance and a significant negative balance, then something is wrong with that data set. Then inconsistency. You have inconsistencies. If account numbers should be 10 digits, if you have a particular account number that is 9 digits, that is some kind of inconsistency, and incomplete, or maybe that is inconsistency. Then you also have incomplete data, maybe where you have first name and the last name is null, is missing. It's incomplete data. We need to really have the person's last name so that we'll be able to know the right name for the person. So all of those cleaning of all of that data will be done in the staging area. So the clean data is now moved to what is called the analytics data store. It's translated to what they call the analytics data store, the ADS. We don't call it enterprise data warehouse. Some people call it enterprise data warehouse. But the collection of what you have in the staging area and what you have in the ADS and what you have in visualization server, everything make up what we call enterprise data warehouse. But in that enterprise data warehouse, there's a component which is the staging area, there's another component which is the ADS, there's another component which is like a visualization server. So on the ADS, that is where you have different data cubes. You have different data cubes in the ADS. You have your models in the ADS. You have your source code. Maybe you are writing Python or R. You have them on the ADS. The business logic or the business rule which are using to mine the data in a particular way, you have it on the ADS. And the ADS can also connect to a data mining tool, like a predictive data mining tool. So this is like an architecture. So in some cases, if you have customers or you have people that say, can you give us the architecture of an enterprise? This is a so, so if you have people asking that, can you give us the architecture of a data warehouse? So this is a very simple architecture for an enterprise data warehouse. Um, I've jumped to slides. I've jumped to slides. So I'll just play you a video and then we'll discuss that video. Oh, sorry. This is a PDF document. So oh, sorry. My microphone has been on mute, so I'm sorry you probably didn't hear me. So I'm going to play. I'm not. The audio didn't play. Oh, so that is strange. So how come? Okay, please show me. So that means nobody had the video. Okay, so show me. Ah, okay, thank you. Oh, okay. So I'm sorry, guys. I played the video 2 times, and you guys didn't hear it. I think I even played it 3 times. So there's no point. So the audio didn't come out. But the guy Imaya showed me how to play but there's no point. I think he's just a lot. It's very explanatory. There was no real video. It's just like a sound playing in the background. So let's move on. So let's just talk about some of those things is which analytics entail and some of those things that are not analytics. So analytics, as I said before, it's looking out for complex relationship between data sets, looking for patterns and relationship between data sets, and when you now have so much data, when you have big data, so much of it is called big data analytics. So again, let's look at one other video on Amazon, how analytics is applied in Amazon. So let's look at it. And so at the end of this video, I'm going to call someone randomly to just explain the content of this video. So let's go. Okay, thank you. Very, very short and concise. So I will call on Ogundele Sunday, Ogunleye Sunday. Please, can you explain? Can you just quickly explain that video to us?
Okay. I think for Amazon, what they actually put in details for their this big data is they look at the user login details and look at the reviews. What can the customer for the product they get to know the review of the user on the product. So basically, for their database, I think they actually need the user, the review of the product of the about the review about the product, and the featuring. And for the collaborative, I think I really enjoyed that side whereby it's talking about engagement. If actually this a particular user is buying like 4 different products and another user is buying 5 products, and they actually filter to look at, okay, is there any relationship between the two, and this will make them to know, okay, this one is much more higher, and just like that. And also they take in concise position for the user, featuring. They look at the history, the likes of the product, and in order for them to be able to store the data of that kind of product.
Okay, thank you. So you are really paying attention to that. So that captures it. User base. I think I explained this earlier on. There is the user-based filtering, collaborative filtering, and there is a hybrid of them. So that is also what you see anytime you are browsing Kunga or you are browsing Jumia. You want to buy an item online, and they are showing you that those who bought this item also bought this particular item. That is the simple technology that Amazon is using to upsell its customers or to cross sell its customers. So a few more information for you before we end the class. So some of these companies, one of those things they do is that they also implement tools that they call session. That is what they call session tracking. So each time you connect to their website, there's a particular code that identifies your computer and also identifies that particular browsing session. And for everything that you click on their website, they track it in a way that will help them to make recommendations and make products, not to make product recommendations to you. So to a large extent, in everyday life, we're exposed to analytics. Also, MTN does stuff like this. You try call, if you have MTN line, try call, oh, not MTN, maybe Nine Mobile. I'm not sure if this still exists. So you call Nine Mobile and call the customer care. What they do is that before you call the customer care, they have already profiled you, waiting for you to call. So by the time you call, they will just tell you that, oh, they resolve your problem. So after resolving your problem, they will tell you that, oh, they notice that you buy maybe 1 gigabyte of data every month. That they have an offer that they can actually give you 5 gigabytes of data for 2,000 naira, but it's especially for you. Ordinarily, 5 gigabytes will sell for maybe 3,000 naira. But just because they wanted to make more money from you, they will tell you that, okay, so we are going to give you 5 gigabytes for 2,000 naira, and it's just for you and for you alone. So when you look at it and you compare that product that offering to what is available in the market, you see that, oh, this is a good deal, and then you dial the code and then you subscribe to it. That is, or that is another way. So for them to make that recommendation to you, they would have profiled you. What kind of device are you using? What kind of data do you buy? Okay, do you have the capacity to buy more data than you currently buy? And so on and so forth. So it's either collaborative or it's user-based or a hybrid of the two. I'm sure if you research more on that, there should be some other hybrid of those kind of applications that are out there in the market. Um, so yeah. So in terms of tools that is used in analytics, there are uncountable tools that are used in different analytics. They are uncountable. So what I recommend to people is learn the first principle. I'm sure the TASCA program and this particular business analytics program or the graduate training program in general is going to expose you to those still fundamental first principles. Is going to expose you to those key concepts. So as I said, there are specific tools that are meant for specific purpose. When you want to store data in a relational way, in a row and column way, maybe you use Excel or you use a relational database. When you want to do predictive modeling, you use tools like Python or R or SAS Enterprise Miner. When you want to do visualization, you use ThinkCell or ClickView or Power BI or what is it called, or Tableau. When you want to deal with big data, big data, very big data that are unstructured data, then you probably need to start considering tools like Hadoop, Hadoop platform. If it is streaming data, the data like Netflix kind of data, then you consider stuff like Spark, Amazon Spark, and so on and so forth. So there's a specific tool for a specific purpose. There is a specific tool for a specific type of data set. You need to know the tool, you need to understand the data set, you need to understand the operation you want to perform, and then you need to know the type of tool that will get it done a lot better. In conclusion for today, let me see how much minutes I have. In conclusion for today, so we are just going to quickly look at the different types of analytics that we have. We discussed different levels of analytics, from raw data to ETL data to standard reports to ad hoc reports, to deep dive to statistical analysis or statistical models, to then building models and algorithms to predictive models, to forecasting and optimization. Those are the different levels of analysis. But today, in a layman way, if I want to explain analytics to a common man on the street, to my mechanic, in a very layman way, what are the different types of analytics? You have a predictive analytics, you have descriptive analytics, and you have prescriptive analytics. There are different durations of all of these. So descriptive analytics is when you are looking at what has happened in the past. These things are very basic. A lot of you already know it. Predictive analytics is, okay, what is likely going to happen in the future. While prescriptive analytics is making recommendations on the best action or the particular forecast. So prescriptive is trying to prescribe, you went to the hospital and then the doctor is thinking that, okay, you might likely have malaria. So what is the best drug we can likely predict for you to prescribe to you to take so that you don't fall sick? It's prescriptive, it's prescription. The same way in business, prescription is also applicable in business analytics, where you recommend the best course of action for a particular business. But you can allow a model or an algorithm to guide you in making those prescriptions, especially when the elements, when there are so many of them. It's very simple. Descriptive is looking at the past, predictive is looking at the future, while prescriptive is more or less about making recommendations. So are we where is our using the slideshow? So just a quick squeeze, a short quiz before we close the session. So I'll just call on you. You will tell me what type of analytics is used in each of these cases that we have here. So when you have sorry. Okay, so I need to get people's name. So I'll start with Adetoro. So when I want to analyze my past year expenses, is it going to be a predictive analytics, or is it going to be descriptive analytics, or is it going to be prescriptive analytics? Hello, Adetoro. Check your microphone is on mute. Is Adetoro on the call? Hello. Hello. Okay. Okay. So Adeto, are you on the call? Okay. So maybe we should move to someone else. So Iola Daniel. So if I'm analyzing past data, is it descriptive or prescriptive? What exactly is it?
Okay. Thank you very much, sir, for that question. Thank you for the lecture also. If you're analyzing past experiences, since it's just past, it's going to be descriptive.
Descriptive. Okay, so let's look at it. Okay, so that is correct. It's descriptive. Okay, so when we want to
Hello,
for
please. Can you
Henry,
still
this
hear me?
question is
I've been
for you.
answering.
Oh,
Girl,
okay, okay. So we'll come back to you. I'm on Henry now. So Henry, when we
all
want
right.
to forecast product demand, so forecasting product demand, there's what they call demand forecast. Um, So there's a mall. So that mall normally stock its inventory with product, but the product is perishable, so it will make sure that it does not overstock. And at the same time, it should also not understock because it needs to also maximize profit. So you cannot afford to also put product on the not have enough product on the shelf in such a way that customers will be asking. Do you understand? So we need to forecast the demand for a product. So Henry, I want to ask you, is that a prescriptive model or is it a descriptive model or is it a predictive model?
Okay, good afternoon, Mr. Blessing.
Speak out, I
Okay,
can't hear you.
can you hear me now, sir?
Better.
Okay, I feel it's a predictive model since we are making a forecast.
Okay, so he thinks his predictive model is correct. Marvelous. Um, so there's a production line and I need to optimize my production and inventory. I need to optimize my production and inventory. So which of the three types of analytics is it? Is it descriptive, is it prescriptive, or is it predictive? Marvelous.
Good afternoon, sir. I that would be prescriptive, sir.
Okay, he got it. Okay, so let's go to Richard. Now I spoke to. Did I speak to Rich? Did I call Richard before?
No,
Yeah,
you've
no,
not
it
called
was
me.
a.
This is our first time.
Okay, so Richard. So Richard, when we are doing churn prediction model, can you explain what churn prediction model? What you understand by churn prediction model, and tell us whether it's descriptive or prescriptive or what type of model it is. Hello, Richard, I can't hear you. Hello, Richard. Okay, so um, let's go to Ibitamuno Tonichukwu. So for a churn prediction, for customer churn prediction model, what do you understand by it and what do you think? What type of model is it? Is it prescriptive or descriptive?
Hello, can you hear me?
Yes.
Okay, I think it's predictive.
You are not sure?
Um, predictive.
You think it's predictive? So explain what you understand by churn prediction model.
Customers strong prediction. I think I predict customer behavior.
Okay, thank you. I think you understand it more as we proceed in this class. So I'll come back to
Hello.
Adetoro. So Adetoro, when we are looking at his historical insight report, what kind of analytics are we performing? Adetoro.
Oh, descriptive.
Okay, so what
Sorry, I
happened to your
was muted.
microphone before?
I forgot I was muted, so I was talking.
Okay, so thank you. It's predictive because it told the identity when we are doing sentiment analysis on the next campaign. So we want to run a campaign and we are doing sentiment analysis on the next campaign that we want to run. What kind of model are we building?
Hmm? Predictive.
Louder.
Hello? Hello. Predictive.
Predictive model. Okay, so the clue there is next campaign. Okay, so Hubert, when we are building a function, an autonomous car, you've heard about self-driving cars. So what kind of models do you think is running within autonomous self-driving cars?
Prescriptive.
Prescriptive. Okay, so thank you, ladies and gentlemen. And if you have any question, please ask me. If there are no questions, please do have a beautiful day.
Good afternoon, sir.
If you're asking a question, you need to project your voice louder.
Okay, good afternoon, Mr. Blessing. My name is Henry. Henry, sir. Okay,
Hi,
nothing too
Henry.
technical about nothing too technical about my question. I just want to inquire if we could get hold of this slide.
Yes, it's part of your training materials. You get it.
Okay, okay, fair enough. Okay.
Okay, so ladies and gentlemen, have a great day. Bye.
Bye, sir. Thank you very much, sir.
Thank you very much, sir.
Thank you, sir.
Bye. Bye,
Bye,
everyone.
guys. You guys
Bye.
can join up on
Thank you
WhatsApp
very
too.
much, sir. Thank you.
Bye.
Bye, Henry.
Bye.
Hello. Are you still there?